Hello learner, in the last class we had started discussing about interference and Newton ring, and now we determine diameter of Newton ring and application of Newton ring. First, diameter of Newton ring. For calculating diameter of Newton ring, assume a plano-convex lens is placed on a glass plate as shown in figure given, where R is radius of curvature in triangle CQL dash. This triangle, we have seen that as per the Pythagoras theorem, we can say that CL dash square is equal to CQ whole square plus QL whole square. It means when we put the value CL dash means this distance between C and L dash, it is suppose R, then we put the value R square, R minus T square plus Rn square, where T is thickness of the air film, R is radius of curvature, R is radius of the circle, C is center of curvature, Q is this point, L is this point, and when we determine the next step, we can say that by putting the value R square is equal to R minus T square plus Rn square, R square, and when we open this square, then we say that it is equal to R square plus T square minus 2RTn plus Rn square, as we can say that T is very less than R, it is thickness and it is radius of the circle. Then we can say that square of thickness is also very small. So equation can be written as 0 means R square cancel by this R square, and T square is very small. Then we can say that Rn square is equal to 2RT. Then equation can be converted into this, and value of T can be given by this. Suppose this is equation 4. In previous section we have given the equation number 1, 2 and 3. Next, diameter of dark ring. First, for the diameter of dark ring, the condition of equation 3, which is the condition of diameter of dark ring, is 2t equal to n lambda. By putting the value of t from this equation, we can say that by put the value of this t, where by putting we can say that Rn square upon 2r equal to n lambda. By cancel out this 2 from this, then we can say that Rn square is equal to n lambda r. When we put the value as r is the radius, then if we determine diameter, then we can say that diameter is the double of radius, means radius is equal to diameter by 2 whole square, it should be equal to n lambda r, and dn square is equal to 4n lambda r. So value of dn is equal to this, or we can say that dn is directly proportional to the square root of this, or this thing is important as per point of view exam or also. Next, we calculate the diameter of bright fringe. Bright fringe, as a previous condition of equation 2, we have already determined 2t equal to n plus minus half of lambda. When we put the value of t from this equation, we give this equation as value of t is from this side this and equal to this, and by cancel out 2 and 2, we can say that Rn square is equal to 2n plus minus 2n plus minus 1 of lambda by 2, and this r is transfers in this position. Then we say that Rn square is equal to 2n plus minus 1 equal to lambda r by 2. As we know that r is radius and diameter is d, then we put the value of r, so we can say that this value is converted into this. When we transpose this equation, then we say transpose or producting this equation by 2, we can say that equation is converted into this, and by 2 and 2 can this 4 is cancelled out by 2, and equation is converted into this, and value of dn is equal to this, where this in this equation this is the condition of bright fringe. Or we can also say that diameter of bright fringe is directly proportional to the square root of 2n plus minus 1 of plus minus of 1, where n is an integer whose value is 0 to n.